SAS, which stands for what? What was another one? And what was the last one? In Detroit, they probably have one called this. All right. That was supposed to be funny. Okay.
SOL.
Save our schools. But I do like that. Sorry, you're SOL. I like that. All right. So we have these three right here. Do you guys think those are the only three triangle congruency theorems that exist?
No.
Okay, a couple more we're going to explore today. So let's get back to this first page right here. This is good stuff today. Pretty short on the notes today. Really just some rules that I want to make sure we hit and discuss. Guys, 12.6 proving triangle congruence by what's the first abbreviation up here, guys? What do you think ASA stands for?
Angle side.
Angle, side, angle, and then AAS. What's that?
Angle, angle, side.
Angle, angle, side. Okay, those are going to be two more that we're going to add to our toolbox, if you will. And the question we need to answer today says this. What information is, what's the word here? Sufficient. Good enough, right? Sufficient means good enough to determine, this should say, whether two triangles are congruent. So the goals that we're going to focus on today, guys. Use the angle, angle, side theorem and angle, side, angle congruency theorems. Okay? We spend a lot of time on congruent triangles. Congruent figures are going to be, again, two figures that have the same size and what, guys? Same shape. So if I draw this right here, if I draw, oh, I don't know, here's a little pentagon. That pentagon, the pentagon people are supposed to protect us. Same shape, guys?
Yeah.
Same size?
Yeah.
Okay. Agree with that? Well, let's look at this right here then. We talk about figures being congruent if we can say, could you perform a rigid motion between the two? Meaning that, again, a transformation that's going to map one figure onto another congruent figure. So between these two right here, let me paste a couple more. If these two figures are truly congruent, shouldn't I be able to slide this, rotate this, turn this somehow so one falls right on top of the other? Rigid motion. One fell right on top of the other, right? Okay. So are the figures congruent? What would you say? You bet they are. Okay. So here's the deal. We're going to start looking at our core concepts right here. Okay. First thing I'm going to type in that box up top is the following. It says, first of all, what does angle, side, angle look like regarding congruency for triangles? I'm going to get you a definition in here quickly. Here it is. Are you ready, boys and girls? I just called you boys and girls. Okay, here we go. Let's get a text box in here. First of all, what is angle, side, angle congruency theorem? You ready for this? Lie to me and say yes.
Yes.
We are ready. Okay, I'm going to make some room here. Okay, angle, side, angle says the following. If two angles and the, I'm going to underline this right here, included side of one triangle are congruent to two angles of another triangle. I should say this. Of two angles and an included side. Underline the word included again. Of another triangle. And what do you think we're going to say about the two triangles? What are we saying? They are congruent. Very good. Okay. Can you guys read that okay, or do I need to zoom that up for you? I'll zoom that up for you. Give me a second, please. Is that better, guys?
Yeah.
Okay, so the two angles on the included side of one triangle are congruent to two angles and an included side of another triangle, then the two triangles are congruent. Okay. Let me know when you have that down, and I'll get some visuals up here in terms of what the heck we're even talking about. Angle, side, angle. Anybody need more time with that?
Yeah.
Okay. Let me know.
Okay.
Trey, are you good?
Yeah.
Almost. Okay. Maddie, good?
Yep.
Good? Okay, let's look here what's going on. I'm going to put a couple of triangles into each box. So I'm going to sketch them like this. Do the first one maybe like so. And maybe, how about this one like, oh, I messed that up. And I'm going to adjust size. Kind of make them like a mirror image of each other, if you would. Does that look pretty close, guys?
Yeah.
Are they pretty close, you think? Okay, here's what I'm going to do, guys. The way angle side angle works is the following. I'm going to set this, I'm going to put an arc right through here, guys. Anytime you put arc marks in here, I'm going to change the color on that so it stands out a little bit more. Anytime you put an arc up here and an arc up here, what's that indicate to you about the angle measures? They are the same. So I've satisfied the first part of this, the angle part of this. Then, after the angle must come a side. So I'm saying this is the side maybe. I put a tick mark here. Where would you put a tick mark at in here then if these two triangles were congruent? On the diagonal, right? Okay. Then if I put two arc marks right here, then I'd have to put two arc marks right down here. Now guys, I want to make sure you understand what's happening here. When we talk about congruency triangle involving angle side angle congruence theorem, we're saying that the side has to be in between two angles. So guys, my angle is here at this vertex and here at this vertex. Okay? These are the two vertices we're talking about that would form the side that we want to have for this theorem. Is that side between these 2 points or these two vertices we're discussing for angles? It is, isn't it? Don't these two vertices make up that side right here? Let me ask you this question right here. If I threw a triangle down right here like this, and I put some measures in here like this, does that represent angle, angle, side? I should say this differently. Does that represent angle, side, angle?
No,
Why not?
because it's not independent angles, it's on.
So the two vertices we're discussing, or the two reference angles that we're discussing are here and here. Does that side fall between those two reference angles?
No.
So I would say this side is included or is not included.
Is not.
That is not included. So you understand the difference between this and what the theorem is stating up here.
Yeah.
Okay. So angle, side, angle, congruency theorem. If you have two angles and an included side congruent to two angles and a congruent side, then these two triangles right here must be what? These are congruent by ASA. Okay, and we'll look at some examples here in a bit. Are you okay with that one, first of all? That's one theorem that we're going to hit hard today. Okay? Have what you need there, this page? All right, let's run on to page 2. Because my next one here, kids, angle, angle, side congruency theorem. So let me zoom this up for you, and we'll type this in. All right, so let me get a text box here, kiddos. All right, angle, angle, side. If two angles and The word I used on the last one was an included side. This one here I'm going to use two angles and here comes the word. What do you think I'm going to throw up here? Non-included side. Whoops, what did I just do there? Of a triangle are congruent to two angles and a, what do you think I'm going to put up in here again?
Non-included side.
Non-included side. Of another triangle. Then what do you think I'm going to say? Then the two triangles are congruent. Very good, Nathan. Sounds very cartoony over there today.
They're watching Cinderella.
Cinderella, Cinderella. I like
Cinderella, Cinderella.
Okay, can you guys read that okay up there? It says again, if two angles and a non-included side of a triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So, this one's an interesting one. Angle side is an interesting one. It's basically the same thing that we had. You're going to have two congruent angles. This time, though, the side is not going to be between the two angles you're talking about. It's going to be on the outside part of it. So, I guess the way that this would look for you guys would be the following. You ready to roll on this? Everybody have this definition? Okay. So here's what I would tell you right here. Here's what I would tell you. If you had two triangles, maybe draw a skinny one like this and one like this. I'm going to stand this one upright. I don't want to do it that way. I can do better than that. Okay. Here's how the labelings would look for this. So I'm going to put an arc mark here. So if I have one arc mark here, where's that going to match, or which one's that going to match in the other triangle? The top part, okay? Those two angles look like they would match. The rigid motion I would use would be some kind of a rotation onto this, wouldn't I? Okay. Now, I'm going to put two arc marks up here. Where would two arc marks go here then? Bottom left or bottom right? Okay. Now here's the difference between angle, side angle, and angle, angle, side. You might say, well, here's angle to angle. Do I want the side to be between the two angles or outside of the two angles this time?
Out.
So maybe I put a tick mark here. Is this the included side between these two vertices right up here where we know the angle measures? So this would be like an angle side relation compared to an angle. Where am I going to put my tick mark at here? Okay. So since I have the order angle to side as I move around here, some people might call this a side, an angle, and angle. You know, whatever. We would say that these two triangles are congruent by which theorem again, guys? AAS. Okay, AAS. So let's see if we can't put these into play right here today. See how these work. Again, we know what each theorem is. Angle, side, angle. We've got angle and included side and angle. Find out if that's present in the other triangle. Okay? Kiddos, I need some help. I need some help in example 1 for labeling. So the first thing I'm going to read up here is this. First of all, which theorem are we using in this example? I'm telling you right here. Angle. Whoops, I think I might have screwed this up. This should actually read angle, side, angle. Okay, so let's change that to this. All right, so you guys help me with this right here. It says, can the two triangles be proven congruent with the information in the given diagram? If so, state the theorem you would use. I need some help first of all with vertices. What's the top left vertice? E? G over here on the right? F? Is G this intersection? Okay. D? The designated hitter.
Nope.
Oh, tricky guys. Is that better?
Yeah, and then
Okay, so there's some tick marks in this, I hope. There's a tick mark here. There's a tick mark here. And then they indicate that angle E and angle...
H are 90 degrees.
You know what? I think I had this right in the beginning. Okay? I think I had this right in the beginning. So we might go back up top and fix this, okay? Guys, first things first. The parts that they give us congruent. They give you a pair of sides congruent, don't they? And they give you a pair of angles congruent. Okay? So we're talking either angle, side, angle, or angle, angle, side. So we need to know how many angles are congruent in this section. How many pairs? Angle, side, angle. 2 of them, right? Or angle, angle, side. Guys, is there another pair of angles up here that you know to be equal?
Yeah.
Where? Why?
Because it shares the 180 degrees.
Yeah. Aren't these vertical lines, or I'm sorry, aren't these the intersecting lines right here? What's true about vertical angles here and here? Yeah, we've known that for a long time. They're congruent. So these angles right here have to be congruent. So I'm going to put an arc mark here for angle DGH and angle FGE. Give me a show of hands. Do you understand why those two angles are equal? Are we cool with that?
Yeah.
Okay. So I had this right up here. The abbreviation was what was wrong. So I'm going to fix this up here quickly. The abbreviation I had was wrong. This should be what right up here for the abbreviation? Angle, angle, side. Yeah, check it out, guys. Start somewhere right here. This goes, is this side included or not included? It's not included between the two angles that we know. So what I'm going to say is this. We're going to say triangle. Let's name this one down at the bottom. Let's go DGH. Is that okay, guys?
Yeah.
Would be congruent to, all right, give me the order on the second triangle. If I start with D down here, F, G, E. F, G, E. Those would have to be congruent. Which theorem? Angle, side, angle, or angle, angle, side? This angle, and that side right here. Okay? We have a 90-degree angle here. These angles are congruent right up here. And then this side and this side are congruent. By the way, what would the rigid motion be for this triangle to match up to this triangle? What type of transformation?
A rotation.
It would be a rotation. Excellent, Britt. Okay? So I'm going to say these triangles are congruent by angle, angle, side. Okay? So can we prove that? You bet we can. Okay, part B. Tell me what we have in B. We have a Q up here. P, PMR. Parson makes ribs.
Ooh.
You want some ribs?
Yeah.
Sounds good.
Does.
What's labeled up here, kiddos?
There's 2 tick marks.
Yep.
Is that it?
Yep.
What kind of triangle is this then? Triangle PQR. What kind of triangle is that? Two sides equal. What kind of triangle? I heard it. Isosceles. So if the two sides are equal right here, what's true about your base angles at P and R? What must be true about angle P and angle R?
They're equal.
They're equal. Base angles in an isosceles triangle are equal. We've discussed that before. Put an arc mark here and an arc mark here. Looks like I have an angle and a side and a side. Now guys, QM is congruent to QM. If I would look at what I have marked here and go in order, it looks like we have A, S, S, right? Okay. Or if you want to do it in a different order, we could have, you know, we'll do one order. You know what? For lack of a better term, I'm going to call it side-side angle. Okay. Is that one of our congruency theorems? No, it's not. So can we definitely say that the two triangles, the one on the left, PMQ, and the one on the right, RMQ, can we say that they're congruent? We can't. Okay, so we don't have enough information. So this is not anything we've explored yet. It may work, it may not. As far as where we're at right now in our toolbox and stuff, we don't know. So this is going to be not enough. What? Not enough info here. All right, find part C here. Part C here on this page. Is there enough information to prove these congruent? This one here, I think, could you prove these congruent by one of our theorems? There are two arc marks down here on this one, and one up here, is that right? How many pairs of angles do we have congruent? Two. Any sides then that are congruent for sure? Where?
MP and PM.
Okay, I should label these. Is this M right here?
Yeah.
This is P. I don't know what this is over here. N?
Oh.
So then MP would be.
So these sides are congruent right here, right? So we do have two pairs of angles that we were discussing in the two new theorems today. Is that side included or not included?
Included.
So which theorem would this work under?
That's the
Okay, by angle side angle. In this one, I could say triangle. How about we go MNP in that order for the first one? Okay, if I go order triangle MNP, what's that make the order on the other?
MLP.
Say that one more time. MLP, right? So I want MNP, so it'll be MLP, right? Very good. Okay. Do you guys see the angle side angle relationship in this one? Okay, and I see something I've got to fix in the way I titled something here, and I'll fix that in a little bit. Okay. Are you guys okay with these three examples right here? Determining if they're congruent or not. All good on that? Okay, anybody need more time with that last, or that second page, I'm sorry. Okay. Kinsey, you got her? Anybody else? I see the other pencils moving. Okay. All right, guys, using angle side angle congruency theorem. Okay, we need to write a short proof as to why the two triangles are congruent. So I need some help here. Let me get these vertices labeled up.
Huh?
The middle's E.
D, E, G.
HF.
Just like this? Okay. So guys, our favorite things to do to write a proof. We need to show that these two triangles are what? Okay, right up here. Right up here, our job. There's two triangles here. We want to show that these two triangles here are congruent. Okay? So again, we'll do this in a two-column proof, but I'm going to take the stuff that's given first.
Yeah.
Okay, step one. What do you know already, guys? DH, segment DH is parallel to what? FG, right? Okay, so we've talked an awful lot about parallel lines this year. So DH is parallel to FG. So that means DH is right here. I'm going to put an arrow in my drawing like this and like this to indicate that those two segments are parallel. You guys agree with that? Okay. What else is given to you as well?
PE is equal to DG.
So the distance from D to E is congruent to E to G. So I'm going to come up in my diagram. I work better when I see the diagram unfolding with the proof. Okay. So I'm going to come up here to DE, put a tick mark. Where else should I put a tick mark, guys? EG. Okay, we need to prove that these two triangles are congruent. So far we have the side, right? We're talking about angle, side, angle today, or angle, angle, side. We already have the side part of it, so how many angles do we need to prove congruent? Two of them. Okay? So let's talk right up here. The reason for number one is given. So let's see if we can't come up with number two. Step two. Any angles you could prove congruent so far in that? At E. All right, so let's talk more specifically about E. Are you saying right here and right here?
Yeah.
So what would the name of this angle be technically in this triangle? DEH. Triangle DEH. So angle DEH has to be congruent to angle, what's the name of this angle right here? GEF, right? Why? What's the reason? Why are those angles congruent? They are vertical angles. Good. All right, now, step three, we'll squeeze in here and then I'll move it over. We've got one pair of angles congruent. Is there another pair of angles I can show congruent? Which one? D and G. How do you know D and G are congruent?
Intersecting lines because they're parallel and then.
Okay, I'm going to do something here quickly. If I would extend this line right here, I'll get rid of these lines here in a second, but if I would extend this line and that line right there, these lines are parallel, right? You said angle G, which is right here, and angle what? D are here. What kind of angles are those as it relates to parallel lines? They're on different sides of the transversal, and they're between the two parallels. They're what? They're called alternate interior angles. So back up here. You guys told me the angle G had to equal, whoops. Angle G has to equal or be congruent to angle what? D, because of alternate interior angles. I'm going to tell you this right now. If any of these proofs today start throwing parallel lines out there, start thinking about alternate interior, alternate exterior, that type of stuff. Okay? So if I write down here as my reason, AIA, what's that our abbreviation for again? Okay, so I'm going to go into my diagram and I'm going to say, all right, well, okay. So angle D, two arc marks, angle G. Take a look at your triangles, kiddos. Enough information to prove them congruent now? How? Reason, I guess. You have an angle and another angle and an included side congruent to an angle and it's its included side. So by which theorem are these two triangles congruent? You bet. So I'm going to put step 4 over here. It smells garlicky. Do you guys smell that?
Yeah.
So I'm going to say triangle. What are we trying to prove again, guys? Triangle D E H is congruent to, and how do you know that again, Nathan? Angle, side, angle, our new one today. Angle, side, angle, congruency theorem. So we're taking things that we've known in the past and combining it with things that we're putting to it today. Right? So I think we have one more example. Is that right, guys? Using angle, angle, side congruence theorem. Let's see what we come up here. Help with the vertices, please. What's top left?
F.
F,
G.
G,
K.
K,
H.
H. Is there anything in the diagram that's given to you at all or not? Can I see this quick, Maddie? All right, just the vertices, right? Okay. So we're going to write a proof. It says given this right here, HF is parallel to what, guys? All right, so HF is right here. I'm going to put a mark here to indicate parallel lines with this. And it also says that angle F and angle K are what? Put a right angle here and a right angle here. Okay. So let's get going on our givens. Number one, HF parallel to GK, F and K are right angles, right? What's the reason? All right, so I've totally butchered the G right there. I don't know what I have. What is that even?
It's A.
I have no idea what that is now. Yeah, that's going bye-bye. Oh, I know what I did wrong. I can fix this. I'm going to fix this. What's the reason? It's given, right? Okay! What else can we prove, guys? GH and GH are. Okay. So I could say GH and GH are congruent by which property? Say it one more time. Reflexive, yep.
We got another 9.
Well, we're going to run out of time, aren't we? Okay. There's the sides that are equal. Hey, we'll pick this up tomorrow, okay?